Hi everyone, this is Mrs. Trigno, and this is the fourth page, I believe, of the Chapter 6 Exam Review for Algebra 1B. This whole page focuses on Newton's formula. So I'm going to go ahead up at the top of the page, and I suggest you do this too. I'm going to jot down what that formula is. You will have this formula provided to you on the exam. Okay. So 15 and 16, pretty straightforward. They just want us to write the equation, okay? Remember, when you're writing the equation, the only places you have to fill in numbers are g, v sub 0, and h sub 0. Of those three, these two come from the wording of the problem, and this g value is always one of two numbers. G is always going to be 32 if you're measuring in feet, or G is going to be 9.8 if you're measuring in meters. Okay, so we're always plugging in one of those two numbers for G. So looking at number 15, it says write an equation modeling the ball's height over time. So my height is going to be, so that's where that starts, -1/2 times, I have to pick my G value. This is being measured in meters, so that means my G value is going to be 9.8 t squared. My initial velocity is given to me here, okay? Initial velocity of 23 meters per second, so that's v sub 0. This is where I got my G from. Velocity would be 23, and notice when I put the 23 in, it just becomes a 23t, like the 23 takes the place of this whole thing. And then h sub 0 is your initial height. That's where we're starting. So we're on a platform 8 meters off the ground, so this is my h sub 0. Now, the only thing I can do to this problem to make it a little bit cleaner is to put together the -1/2 and the 9.8. And I do suggest that you do that. So my equation would be -4.9 t squared plus 23t plus 8. And that is my answer. So now let's see the next one. A ball is dropped from a platform 19 feet, so this one's in feet. When I get to my G value, that means I'm using 32 instead of 9.8. T squared plus my initial velocity. I don't see an initial velocity here. Anytime you're missing a velocity, look for this. Is the ball just being dropped? Okay, they have to give you the velocity. Them saying that it's being dropped is telling you that you're not putting any force behind the ball, so that tells you that your velocity is 0. So I can put a 0 in here. So I would say anytime you're reading a problem and you go to look for the velocity and it's not there, look to see if this is what's happening. Okay. Now, if it's not, there's really not a way to solve the problem. I mean, if you're throwing it or launching it or whatever, there has to be a velocity given. And then our platform is 19 feet off the ground. That's our h sub 0. So that'd be 19 down here. And then this time, I can clean up this. And I can also get rid of that 0t. I don't really even need to write it in my problem. So my equation would be h equals -1/2. I'm sorry, -1/2 times 32 is -16 t squared. My 0t went away, and then this would just be plus 19. And that would be my equation for this one. Okay, so 17 and 18 are also Newton's formula problems. They don't tell you to write an equation, but without an equation, you're not going to be able to do any of this other stuff. Okay, now I will also tell you that for both of these, you can do all of these things on a graphing calculator. And we've talked a lot about how to do those things. So you could use the graph on your calculator to answer these questions. Quite honestly, I just don't have a graphing calculator here at home, so I'm going to show you how to do these by hand. And maybe that'll be a relief for those of you who are struggling with how to do it on the calculator. Okay, you know some of this other stuff, so why not use it? So for this first one, again, I have to write the equation, even though it doesn't say write an equation. So I'm going to say h equals -1/2 times my g value is 32 because I'm measuring in feet, t squared, plus an initial velocity of 5 feet per second. So that'd be 5t, and then plus from a height of 3 feet, so that'd be +3. And again, if I rewrote, it would be -16t squared plus 5t plus 3. Okay, for these first two questions sort of go together, okay? Because notice they're both talking about the maximum height. And if you think about what this would look like on a graph, okay, here's your paper airplane. It's going to go something like that, okay? So both of these questions refer to this point right here. Think about what I would call that point. That point is the vertex. So if I can find the vertex, I can answer these questions, okay? And I do know how to find the vertex. Finding the vertex is h and k. So, and now be careful here, because that h is not the same as this h. This h stands for height, but remember when we're finding the vertex, we name the vertex with h and k. So it's a little confusing that they use the same letter. So if I want my h value, that's -b/2a. So from this problem, that would be -5 over 2 times -16. If you're putting that in a calculator, that bottom part's going to need to be in parentheses. So -5 divided by, let me get you out of the glare a little bit, -5 divided by 2 times -16. Oh, see, I just didn't follow my own advice. That would have gotten me into trouble. 2 times -16. And I get 0.15625. Okay, so that's my h value of my vertex. Okay, and then to find my k value, it's going to be kind of a tight pinch, but I'm going to take this h value and plug it into my equation for x, which is really now t. Okay, so I'm putting this in place of t. So I would do -16 times point, and I recommend just keeping that whole decimal. I know it's kind of tedious to write it out, but your answer is going to be much more exact that way. Plus 5 times 0.15625 plus 3 equals, let's see, -16 okay, and I get, now here, because this is sort of my final answer, I'd feel comfortable rounding that to like 3.4. Okay, so we found these two numbers. Let's talk about which number is which. Okay, remember h and k are like your x and your y value of the vertex. So the x comes first and then the y comes second. And in this problem, x represents time and y represents height. So when I ask this question, what is the maximum height, you have to ask yourself, am I looking for a time or am I looking for a height? In this one, I happen to be looking for the height. So my final answer is this 3.4. Okay, and that'd be 3.4 feet. I should have labeled that. Okay, 3.4 feet off the ground is the maximum height that this paper airplane is going to go. Okay, so again, I don't know how to best connect that, but maximum height is 3.4. Now, if you look at this next question, how long before the plane reaches its maximum height, isn't this asking for a time? Okay, and my time was right here, so it would be 0.15625 seconds. Okay, so I can find my vertex, And finding my vertex answers both of these questions because both those questions are asking things about this point here. Now, if my math was correct when I helped out quite a few students with this one, this next question doesn't make sense. Okay, and that was my fault. This is a badly asked question. I want to go ahead and work through it mathematically and then see if we can talk about why it doesn't make sense. So, how high is the plane after 1.5 seconds? We want to somehow be able to plug this into the equation. The question is, does it get plugged in for h or does it get plugged in for t? Well, it's in seconds, so that's a measure of time, and time is my t value. So I'm going to plug it in for t. And those ones are easy because you're just plugging it into a calculator. So I would say h equals negative 16 times 1.5 squared plus 5 times 1.5 plus 3. Okay, let's plug it in and type away negative 16. And enter. Okay, and this is the part that gets a little dicey. As an answer, I get negative 25.5. Okay, let's think about why that answer doesn't make sense. I'm going to go ahead and box it in because that is the correct numerical answer, but it's not a logical question. What this is saying is that my height at 1.5 seconds would be negative 25.5. That means this is technically underground. This is like if you threw the paper airplane into a canyon, okay, after 1.5 seconds, it would be 25.5 feet below where you started, okay? So it doesn't have any ground resistance, but you're probably not throwing a paper airplane into a canyon, so this was really a bad question. And if you think about it, it reaches its maximum height at not even half a second. So by 1.5 seconds, this thing is already on the ground. And that's why we're getting this crazy answer. So this was a bad number for me to have chosen to give you. My fault, not yours. But mathematically, that's what you would do with that, is you would plug in whatever number it gives you for t. And then approximately how long before the plane lands on the ground. You know what, on this one, I really recommend, especially since it says approximately, that you use your calculator. And we can go over that in class if you need to. To do it by hand, you would have to use the quadratic formula. And on that previous page, we just killed the quadratic formula. So I don't know that we need to do that again. But since it says approximately, what you can really do is look at it on a calculator. Now you will have to adjust the window. Look at it on a calculator. And remember, these little tick marks give you like the number of seconds. Okay, so you would just estimate from here how many seconds before it hits the ground. Now this is not accurate. Okay, because like I said, it reaches its maximum at less than half a second. Okay, like way less than half a second. So probably I would guess like 1 second is all it needs to land on the ground. But if you want, you can check out under Chapter 6. There are several videos of Newton's formula that talk about how to do these different things on your calculator. So if you're stuck on the calculator stuff, that's where I would check. Okay, let's look at 18. 18 is going to be really similar. I need to start by writing my Newton's formula equation. So negative 1/2. My g value is going to be 32 t squared. My initial velocity is 72, so 72t at an initial height of 4.5. So that means my equation is really negative 16t squared plus 72t plus 4.5. Again, these two questions are asking about the vertex. So if I can find the vertex, I can answer both of those questions. On your calculator, you can look under the calc menu and use maximum, the maximum option. Remember, that's where you have to set the left bound and right bound. And again, if you need more guidance on that, please check under Chapter 6. There are several videos of those examples. So with this one here, I would find my h and my k, start with h, And actually, I think what I'm going to do, I'm going to find h down here because I know the question how long, that's my t value, which is really like my x value, okay? And in my vertex, the h is the x value of the vertex, if that makes sense. So I know that I'm going to be finding h and k. I'm finding this. This is my t, and this is my h in terms of Newton. So this is my time and this is my height. So this question about time means that my h value is the answer to this. So I'm going to go ahead and do this down here. Negative b, so that'd be negative 72 over 2a, so 2 times negative 16. That's going to be negative 72 divided by negative 32, and I get 2.25. So that's 2.25 seconds. Okay, that's how long before I reach my maximum height. Now to figure out what is the maximum height, I'm going to take this 2.25 and plug it into the equation. Okay, so I'm going to say, I'm going to plug it into the equation, and that's going to be my answer for this one, for this, I guess, question number 1 under that problem. So I would say h equals negative 16 times 2.25 squared plus 72 times 2.25 plus 4.5. And my final answer for that is, drum roll please, plus 72 times 2.25, 85.5 feet. So again, I found that would be like the k value from my vertex. But the k value for my vertex represents height in this problem. So your vertex is always time and then height. Okay? Gosh, that's looking a little messy if anyone's trying to follow that, but hopefully that made sense. Okay, how high is the ball after 2.5 seconds? Let's just use some logical thinking for a second. I know from back here that at 2.25 seconds, I'm at a height of 85.5, and that's my peak. So 2.5 is a little bit past the peak, meaning I should be finding an answer that's a little bit lower than 85.5. Okay, not sure how much lower, depends on how fast it's moving, but it would be a little bit smaller than 85.5. So again, to do this, 2.5 seconds, that's my t. So I'm going to go into the equation, and I'm going to say h equals negative 16 times 2.5 squared plus 72 times 2.5 plus 4.5. Okay, and I get 84.5. And that's pretty much in line with what I thought a second ago, is that it was going to be something a little bit smaller than 85.5 because it's on its way back down, but it's just past that peak. So again, good to think about those things just to make sure your answers make sense. And then again, approximately how long before it hits the ground? I would guess close to 5 seconds, 4 to 5 seconds. I'm making that guess because I know it reaches its peak at 2.25, so that's sort of the halfway point, but you have to be careful because it didn't start on the ground, but it ended on the ground. So that's not always going to work. You can't always just double that, but just to tell you, when you look at your calculator screen and you look at that picture, if I had to guess, and again, if you want more specific direction on this, check under Chapter 6, Newton's formula, that you're going to see something like this. It's going to be somewhere between 4 and 5 seconds that that ball hits the ground. Okay? So again, for this, we're going to use a graphing calculator. I don't have one here to show you, but I've got plenty of other videos up that could help you with that if that's where you're struggling. Okay, that's it for our buddy Newton. We'll pick up with the other properties of parabolas and things like that in the next video.